In this lecture, we discuss about Cauchy's mean value theorem. Let us first define or take the statement of Cauchy's mean value theorem. Let fx and gx be function of x defined in the open interval ab such that condition number 1, f of x and g of x both are continuous in the closed interval ab. Second condition, f of x and g of x both are differentiable in the open interval AB. And the third condition, g of x never 0 for any value of x in the open interval AB. Then there exists at least one value of c of x in the interval AB such that f of b minus f of a divided by g of b minus g of a, which is equal to f dash of c divided by g dash of c. So this is Cauchy's mean value theorem. Let us take one example based on the Cauchy's mean value theorem. Verify the Cauchy's mean value theorem for the function f of x equal to e to the power x, g of x equal to e to the power minus x in the interval AB. Let us verify the Cauchy's mean value theorem for the function f of x equal to e to the power x and g of x equal to e to the power minus x in the interval AB. So we know that what is Cauchy's mean value theorem? Let fx and gx be functions of x defined in the open interval AB such that f of x and g of x are continuous in the closed interval AB. Second, f of x and g of x are differentiable in the open interval AB. And g of x, which is not equal to 0 for any value of x in the open interval AB. Then there exists at least one value c of x in the interval AB such that f of b minus f of a divided by g of b minus g of a, which is equal to f dash of c divided by g dash of c. So this is the main expressions of Cauchy's mean value theorem. Here, f of x, now we have to verify the Cauchy's mean value theorem for f of x is equal to e to the power x and g of x equal to e to the power minus x and in the interval a, b. Since both functions f of x and g of x are exponential function, and we know that exponential functions are always continuous, therefore, the given functions are continuous in the closed interval AB. Second property, let us try to find out f of x and g of x are differentiable in the open interval or not. Differentiating 2 with respect to x. So derivative of e to the power x is e to the power x and derivative of g of x, which is e to the power minus x, is minus of e to the power x. So e to the power x, derivative of f of x, and minus e to the power minus x, derivative of gx. So clearly, if we put any value lying between a and b, the values of e to the power a and e to the power b will be always exist. F dash of x and g dash of x exist for all values of x in the open interval AB, which means that f of x and g of x are differentiable for all values of x in the open interval AB. Now, let us prove the third condition. G of x is not equal to 0 for any value of x in the open interval AB. We have from equation number 2, g of x equal to e to the power minus x. It is always non-zero for any value of x in the open interval. a, b. We know that the minimum value of e to the power minus x is 0. It is for x is equal to infinity. If we put e to the power minus infinity, then its value is 0. Rest of the time means for all value of x, its value exists for in the open interval AB, because minus infinity, or we are not going up to the infinity. All values lying between a to b at g of x will never become 0. So since all the properties or all the three conditions of Rolle's Cauchy's mean value theorem are satisfied by the given two functions, therefore there exists at least one value c in the open interval AB such that f of b minus f of a divided by g of b minus g of a, which is equal to f dash of c divided by g dash of c. Now f of b is e to the power b, f of a is e to the power a, g of b is e to the power minus b, g of a is e to the power minus a, and f dash of c is e to the power c, f dash g dash of c is minus e to the power minus c. Now, we won't change. Numerator is same. Denominator e to the power minus b, e to the power minus b, and e to the power minus a can be written as 1 upon b e to the power b and 1 upon e to the power a. Similarly, this e to the power minus c can be written as 1 upon e to the power c. Now, if we take the LCM of this part, which is e to the power b into e to the power a, and if we simplify it, e to the power a minus e to the power b, which is equal to e to the power c goes to numerator minus of e to the power c into e to the power c. Here, this and this term both are same, so both will cancel, and e to the power a into e to the power b will go to the numerator. Therefore, we have e to the power a into e to the power b, and this one is e to the power b minus e to the power c. Now here, we will take the minus sign over here. So minus sign we have taken outside. This two will cancel. This minus and minus will be cancelled. We have e to the power a plus b equal to e to the power 2c. If we take antilog on both the sides, so we are getting 2c is equal to a plus b. Therefore, c, which is equal to a plus b by 2, and definitely c is nothing but a mean value of a and b, means it is the middle value of a and b. So clearly c lies between the open interval a and b. Hence, Cauchy's mean value theorem is verified for the functions f of x equal to e to the power x and g of x equal to e to the power minus x in the open interval a, b. Thank you.